Hello, so I'm going to look at this question. If you're given a trig function of an angle, like in this case cosecant of theta, and you're asked, for this ratio, find the angle for which this is true. How do we address that? So let's go, first of all, let me mention that if you're asked this kind of question, they're not going to give you a number that you won't recognize, or a ratio that you won't recognize. So they won't say something like cosecant of theta equals 2.7. It's not going to be like that. If they're giving you something like this, what they're asking you for is one of the special angles on the unit circle. So one of the quadrants, like 0 degrees, 90, 180, 270, or 360, or it looks like my cat might help us, a multiple of 30 degrees, 45 degrees, or 60 degrees, any of those. Okay, so let's go to that question. So again, let me translate this a little bit more verbally. Remember, your unknown is this one. It's the angle. So you're really asking for what angle, in this case, the angle, the name of the angle is theta, in the interval from 0 degrees to 360 degrees, where 0 degrees is included and 360 is not, because it's a parentheses. So basically, once around the circle is all you're doing. Is going around there and looking for the solution for which this ratio, the cosecant of this angle is this ratio, and that's true. So what I would do is this. First, I would say, okay, what's the definition of cosecant? Well, the definition of cosecant is r over y. So you're really asking for what angle theta in the interval from 0 to 360 is the ratio r over y equal to 2 square root of 3 over 3, right? Now, let me just mention here that this might be a little hard to recognize at first, but if I'm looking for r over y, I can use the unit circle. So why is that? Well, the reason I can use the unit circle is because, again, if you look at concentric circles, for example, and you said, hey, I'm going out a certain angle of rotation, there's my angle. What's happening is I can create an infinite number of what? Right triangles, right? And therefore look at their ratios, and their ratios will be the same. So what's happening is, remember, for any particular angle, you can create an infinite number of similar triangles, right? And they're similar because they're all right triangles. This angle is the same, so therefore these angles must also be the same. So this is definitely similar to triangles. We're not saying that the lengths are the same. We're saying that the ratios are the same. So what do I mean by that? So that means that the ratio of this side, for example, to this side, which would be, let's see, what, cotangent, right? X to y, is the same as this length to that length. That ratio is the same as this ratio here. So the lengths are not the same, because obviously this is shorter than that. But the ratio of this to this, and this to this, and this to this are all the same. And of course, there's only 6 ratios that are possible. So of course, all the 6 trig ratios are the same for that particular angle. So that was a long-winded explanation, but to say, why is it that I can choose the unit circle, where the unit circle I choose on purpose because the radius is a length of 1. So therefore I can say 1 over y is 2 square root 3 over 3, right? So I chose that particular circle. Now what I want to do is I want to make this a little bit more recognizable, because I'm looking for the y coordinate that has this kind of relationship, but I don't really recognize this yet. So it was probably rationalized, right? So the idea is it was probably something that had the square root 3, right? One of these angles here. But I still don't recognize it because I know the unit circle had the square root 3 over 2. So let me see if I can, change out the rationalization. So I multiply by 1. So that here, I'm really saying that this is now what? 2 times 3 over 3 square root of 3. The 3's cancel out, so now I have 2 over square root of 3. So now what I know is I'm looking for the angle in this interval for where the ratio 1 over y is 2 over square root of 3. Excuse me. And of course now, because I want y in the numerator, take a reciprocal, I'll have y equals square root 3 over 2. Now I recognize this question. Now I finally can say, I want to know for one angle in the interval from 0 degrees to 360 degrees, is the y coordinate a length of square root 3 over 2? There we go. Now I can recognize this. And now I say, oh, well, let's see. The y coordinate square root 3 over 2 here at 60 degrees or pi over 3. And where else? Over here at 120 degrees or 2 pi over 3. So since this is in degrees, we'll say 60 degrees and 120 degrees. So that's the answer to that question. Thanks so much for listening.